In the last episode, we talked about DevOps and Azure SQL. In this episode, we'll dive deeper into how Azure Pipelines plays into all of this. Learn more on this episode of Data Exposed. Hi, I'm Anna Hoffman, and welcome to this episode of Data Exposed. Today, I'm joined once again by Arvind, a program manager on the Azure Data team. Thanks for joining us again.
Hey, thanks again for having the opportunity to talk to you all.
Always a pleasure. And today we're going to continue our conversation about DevOps. And, last time, Arvind, we talked a little bit about imperative versus declarative database development type of paradigms. I was wondering if you could start by just kind of reviewing what that is before we get into some cool demos that I know you have planned.
All right. Thank you, Anna, for the question. As you remember, last time we spoke about different approaches, and the two predominant ones that we discussed, we deep dived into change-based approaches last time, which is like specifying the how. And you probably recall the kind of cheesy analogy to the pizza thing that we talked about, wherein in change-based approaches you specify the how. Again, as a reminder, if you want to go into some depth, there's a neat little blog post that we wrote which summarizes both these approaches. So there's state-based and there's migration-based or change-based. Today, we're going to look in depth on state-based. I think state-based has been around. It's been around till for at least the last decade or more, if I'm not mistaken. Unfortunately, it doesn't get all the limelight that sometimes other approaches might get. The state-based approach involves you as the developer specifying what you want to get out at the end. You want to get to a table with X number of columns, or you want to store procedure which has a bunch of code. You don't worry about how to get there. So, for example, you have a database already in prod. You just declare the final state, desired state to get to. And the tooling that we will show you specifies or internally allows you to get into the how. And that's, in my opinion, a very powerful capability because it kind of takes a little bit of the the nuts and bolts out of the picture, wherein you don't have to worry about alter statements and so on and so forth. But it does have that little bit of an abstraction. So you lose some of the control over exactly how those migrations are made. And that's kind of the trade-off that we've seen, wherein some users and customers like to have that hands-on feel where they want to get into the how and they want to explicitly control how those changes are made. And that's when they'll use these change-based approach, like using DBUp or Flyway or one of these other tools out there. With declarative approaches, you don't have to worry about the intermediate steps, if you may. So that's kind of the quick recap, if you may, from the two approaches.
Thanks, Arvind. It was great to have that recap, and I'm looking forward to learning more about this approach. Why don't you go ahead and share your demo with us? I'd love to see it.
Sounds good. I'm going to be using a tool of choice, in my case, a tool of choice, which is Visual Studio 2019. And Visual Studio 2019 comes with something called SQL projects. Some of you might have heard about SSDT in the times past. SSDT stands for SQL Server Data Tools, but it's actually not just for SQL Server. It's also for Azure SQL. What I have in front of me is a project. It's actually the same database that we looked at in the first episode, wherein we looked at a fitness tracking application, a very simple database to track fitness activities. And the difference here is that we have a project ecosystem within Visual Studio. I'm going to quickly kind of show you how this looks. The key thing you will notice is, it's of course in Visual Studio, so it's a slightly different look and feel. There's some pros and some gotchas that you might want to keep in mind as well. But mostly it's pros. So let's take a quick look. So here's the table that we created the last time around. It's the same table, as you can see, looks good. But the main thing that I want to point out at this point in time is that with a SQL project in Visual Studio, you have all the design time, safety, strictness, whatever you want to call it, as you would be with, let's say, a C# project in conventional Visual Studio. So for example, if I take the distance column, and I look at find me all the places that it's referenced. This is actually doing a symbolic search. And what I mean by a symbolic search is actually understanding the structure of your project and finding out all the places where that column is referenced. It's not going to find, for example, a comment where you had the word distance, because a comment is considered like not an object. It's just a text out there. So this is very cool because I think it does enhance developer productivity, saying, hey, find out where this column is used. It's so simple to talk about that, but it's a very effective way of accomplishing that requirement. Other things you could do is, let's say I want to change this column, which says type, because I don't want to use like what looks like a kind of a reserved word. I can do a rename, and I can say, say call type or session type. So if I do this, as you notice, it says preview changes. There's a very cool, kind of a preview saying, hey, this change that you're going to do actually affects your stored procedure. And if I zoom in on this, it's actually going to show me exactly where in the stored proc is that change going to impact. I think this is really powerful because refactoring is not just find and replace anymore. It's actually done through a formal system of record, if you may, the project system. The last thing I want to show you with respect to the project is this thing called code analysis. And this is something I'm very, very passionate about. Visual Studio SQL projects allows you to do some really cool things with code review. So I ran code analysis, and as you can see, it's completed. When I go to the list of errors here, you can see there's a bunch of things that comes through. And you can also see there's references to something called carnage.code.data.rules. This is actually an open source project that's out there, which adds a lot of custom rules to Visual Studio SQL projects. These are very, very useful. At the same time, they can be a bit noisy at times. So what you can do is, if you wanted to specify exactly which rules you want to run, you can go back to the project properties and select or deselect the ones that you really want in your project build, if you may. So as you can see, there's a lot of code quality things that you can do out of the box, and each one of these is using that rich project system. So it's not going to, the tendency to report false alarms or false positives is minimal. It's not zero, because as with all software, there's always a chance that you might get a false positive, especially with things like this. But it's extremely powerful, in my opinion. And code quality checks at design time is one of the strong distinguishing factors, in my opinion, which sets aside a tool from the other. So that's chalk that up for SQL projects in Visual Studio, if you may. Now, that's the design experience, if you may, the development experience. How do we deliver all this? And for this, I want to actually switch context and show you kind of a background of a demo that I'm going to show you. So let's see how all this comes together. And in the context of this demo, what I'm going to show you is a slightly more complex environment as compared to the one that we saw in the previous episode. In this example, we have an Azure SQL database that's deployed into a private virtual network in Azure. As some of you might know, Azure has private link, which is a neat way to tie down your resources to be accessed only from a specific virtual network. Many enterprises and some security, who's not security focused, but a lot of organizations demand this kind of a deployment. So what this means is that if I were to deploy changes to this Azure SQL database, I need to have access to it. And typically, if you're running public cloud-based pipelines like GitHub Actions or even Azure DevOps pipelines, those agents, as they're called, by default live in the public cloud, which means they don't by default have access to your private network. So what we have in this particular case is I created something called a self-hosted agent. A self-hosted agent is a neat feature in Azure DevOps wherein you can create a VM in your own private network. And this could be, sometimes you could have an agent on premises, where if you're dealing with a hybrid deployment scenario where you want to have VMs on-prem and so on. The VM that I deployed is just Windows 2019, and it has the nuts and bolts which are needed to get to run Azure DevOps tasks. I'm talking a lot about Azure DevOps, but I haven't really shown you what Azure DevOps is. So let's take a minute and review what Azure DevOps is. So Azure DevOps is Microsoft's software as a service or platform as a service option, depending on how you look at it, a solution for DevOps, and it's for certain use cases it's actually free. You have to look up the terms and conditions, but I think it's a very neat option for especially for smaller projects where you have just 5 developers or something. It's actually free out of the box. I have a sample project set up in Azure DevOps, which is just called e-commerce in this case. The name is not particularly relevant. But I just want to spend a minute. Azure DevOps neatly snaps to those 4 quadrants that we started off with the DevOps lifecycle, if you may, wherein you have boards functionality. The boards functionality allows you to plan your project. So as an example, you can see your backlogs, your sprints, you can assign tasks to developers on your team and so on and so forth. So that's the project lifecycle. We have repos where you can actually see your code. So let's take a minute and take a look at this. So we have multiple repos in this project. One is the famous wide world importer sample, and one is our fitness tracking application here. We're going to spend some time looking at the code in this, so I will keep that open. The next thing that I will again show you in detail is pipelines. Azure Pipelines is the kind of the heart of what we're going to show you in the demo, wherein you have tasks that can be run in an automated and repeatable way, which allow you to deliver the changes that you want to deliver to a database. Then there's a bunch of other functionality which we're not even going to touch upon because there's so many of these things like testing and so on and so forth. Now let's rewind again and take a look at the big picture. Recall in that in the demo overview that we have a private database that we want to deploy changes to, and that private database is only accessible from the context of that virtual network. The project that we have here, as you can see, let me switch back to Visual Studio, had these basic changes in place. So like I have a table which has the adjusted distance, but it doesn't have the temperature column that we wanted to add. So what I'm going to do is kind of close this up and then switch branches. I already staged a change, which we're going to use for this demo. And let me go back to Git, and I'm going to say git checkout at temps. This branch has a change which adds a temperature column to the table. And the important thing that I'm going to show you here is how it actually reflects in the create table statement itself. Notice that if you go back to the previous video, when we added a temperature column, we had to write the how, which is we had to write an alter table statement. In this approach, which is using SQL projects or sometimes referred to as SSTT projects, we don't tell it how. We just say, hey, you need to get me to this end state, to this desired state. You figure out how you're going to get there. And the you that I refer to metaphorically in this is the tooling that's behind SQL projects. So SQL projects is actually powered by underlying libraries called DACFX, our DAC framework. And it also comes with a library called, or a command line tool called SQL package. SQL package.exe or SQL package command line in the case of Ubuntu or Mac, for example, because that is a cross-platform tool, is the one that's actually used to take your changes and deliver them to database. And you may be wondering, how is all that coming together? So when you build this project, you can actually build this project just like a traditional C# or a C++ project. What comes out of it is a set of outputs. So in this case, actually producing a DLL, which we are not using. But the most important thing that it produces is this thing called a DAC pack. A DAC pack is a kind of a compressed model of your database. So it stores the state, the desired state of your database. And these tools like DACFX, SQL package, and so on, use DAC packs to kind of compare the state that it needs to be at with the state of the target. So if the target is at a version which is earlier, it's actually going to do a schema comparison. And based on the schema comparison, those tools produce an alter script for you, or will run the alter script automatically for you on the target. So that's the declarative approach. And the best way to see all this come together is to take a look at a pipeline. So let's switch context back to Azure DevOps, where we have a pipeline which is created for deploying our SQL project. I'm going to switch to a branch that has a rich pipeline that I'm going to show you for this demo. So let's see if we can move this out a little bit. And here we go. So this is a pipeline that's, again, there's a lot of code, but the key things you want to keep in mind are that this is declarative. So it's YAML based. It's a rich declarative syntax. The key things to keep in mind are that it uses multiple stages. This is a very, very powerful capability, wherein I can have different stages, each of which is running in a different context, and then doing stuff. So just keep in mind that for a database to be deployed to, it needs to exist. So in this case, one of the stages, the first stage that is actually here, is creating a database. And it does that by using AZ SQL DB. So this is AZ CLI. It's all parameterized. All of these come from variables within a library. So nothing is hard coded. And guess what? It's running on Ubuntu. The reason I show this specifically is because if you had this database deployment as part of a larger deployment, let's say you have Kubernetes, deployments that you want to do as part of this overall orchestration, you could run that from, let's say, an Ubuntu runner. And the Ubuntu runner works fine in this case because all that it's doing is it's talking to Azure. It's not actually talking to my database right now. So even though it doesn't have connectivity to the private network that I'm deploying things into, it works just fine. So this is going to, declaratively create a database, and it's idempotent. If the database already exists, it's just skipped. So you kind of don't change stuff that's already there. The next stage is it builds a DAC pack. Again, there's a lot of code here, but the key things to keep in mind is that it does essentially what I did in the demo earlier, wherein I did a right click and build. It's going to do the same thing in the context of a pipeline. And it's going to save artifacts into Azure DevOps. These are effectively like zip files that Azure DevOps stores. And again, I'm pointing this out to you because these are a lot of the characteristics. These are addressing a lot of those characteristics that we want out of DevOps experience, which is you have repeatability, you have auditability in the form of these artifacts. You can actually go back and say, hey, what actually got deployed, that particular build? You can go back, you can actually look at the artifact, you can see the DAC pack that was deployed on that server. And then last few things to keep in mind when I'm deploying, and in this case, I'm deploying to production. So you want to have some approval in place. You want to have some workflow which says, let's take a second set of eyes, verify that this is a safe deployment to do. Though we trust the pipeline, sometimes you do need a human to kind of hit the approval button. So I'll show this to you in a minute what it manifests as, but we have an approval stage, if you may. And last but not the least, we deploy the DAC pack. We actually take the DAC pack, use this inbuilt task within Azure DevOps, which is called SQL Azure DAC pack deployment. So we didn't have to write specific code. This task comes out of the box with Azure DevOps. It uses SQL package internally, and it's going to connect to the database that we need to deliver these changes to. And this is the same database that we created upfront earlier in the pipeline. To kind of wrap things up, I want to show you how this all looks in a real execution. I have preceded a pipeline execution in this case, wherein it is queued up and it executed this multi-stage pipeline. So I'm going to expand these to show you what's going on. You recall from the YAML that we saw, there were 3 distinct stages. We create the database, we build the DAC pack, and then we deploy the DAC pack. You see those stages are reflected here in this multi-stage pipeline flow. So we first created the database, and if I click on that, I'll do that in a minute. you can actually see the nitty-gritty of what happened under the scenes or behind the scenes. Then it built the backpack and it saved an artifact. This is cool because I can now go back and see what was the build output it produced. But guess what? We're stuck because we're waiting on approval from a third party. In this case, I have queued up a reviewer who is going to approve this workflow. So I'm going to just go back to the other screen, which is a different user in Azure DevOps. This is a PR reviewer user, which I just created for the purpose of this demo. And as you can see here, it's a pending review from this person. The person can choose to reject or approve. I'm going to be generous and approve it because want to see this kind of flowing through. When this flows through, if you give it a minute or two, it's actually going to go ahead. You see, it says check passed. This is a good time to probably rewind and look at a previous run where we have the the full workflow completed. And what I want to do here is show you the jobs view. This is where the proof of the pudding, so to speak, it can be seen. So we have a create DB stage. I want to zoom in on some of these little things that I think are very useful to know. Remember in the YAML we had specified the first stage runs on Ubuntu. There's Ubuntu right there for you. So this is running on Linux. It's running AZ CLI. And it does a bunch of stuff. I'm not going to bore you with all the details, but it just created a database for me. The next step was to build the DAC pack. The DAC pack, again, the key thing to keep in mind is that it's producing exactly the same effect as doing a right-click build in the context of Visual Studio. So here you can see it's throwing warnings because some of my objects have design time problems, like they have a different case, like uppercase, lowercase mismatch. But in the end of the day, this is important. It produced the DAC pack and it saved it as an artifact. So you can see next, the next step is it saves an artifact into Azure DevOps. The last few things here, you see in the previous run, approval was granted, and then it actually deployed the DAC pack. The deployment of the DAC pack uses this utility called SQL package. This is running on Windows. It's running on the VM that's in my virtual network. So it's actually having access to the private link based SQL DB. What you see here is it published to this database that's on that server. In this case, the deployment plan is empty because the database that I had was already in the state that it needed to be. So idempotency again. You rerun pipelines n number of times, it's not going to error out because it sees the changes already in there. So this is a bit of a whirlwind tour, if you may, but the key things to keep in mind are, Azure DevOps is there's a plethora of features out there. There's solutions for all 4 phases of the lifecycle, if you may, from a DevOps perspective. And from a pipelines perspective specifically, the key thing I want to emphasize is that Azure Azure SQL has native support in the form of the Azure DAC pack deployment task that you saw earlier, right? So just to kind of recap, everything that you want to deploy in the pipeline in the form of the pipeline tasks is in YAML. So that was a bit of a whirlwind tour around Azure DevOps and what it means in the context of Azure SQL. The key things to remember are that Azure DevOps is a full-featured DevOps platform, if you may. It has solutions for each of the 4 quadrants that we saw earlier: plan, develop, deliver, and operate, if you may. In Azure Pipelines specifically, you saw how the declarative nature of a pipeline in the form of a YAML based markup is extremely powerful, and it's actually quite simple once you get used to it. And the last thing I want to emphasize is that there's native support for deploying to Azure SQL in the form of the Azure SQL DAC pack deployment task, which can not only do DAC packs, but SQL scripts as well. So hopefully that gives you a very quick overview of the broad world of declarative database development with Visual Studio and Azure DevOps.
Thanks, Arvind. This is definitely a lot to cover, and we appreciate your time so much hanging out with us and showing us all of these things. Just one last question as we wrap up. You showed us the imperative and the declarative, and I know there are use cases for both of those scenarios. For someone who's just getting started or just kind of getting into this space, what do you think, the right approach to take would be?
Again, it's going to depend. I'm going to give the classic SQL answer, which is it depends. But if you were to push me and ask for one option, I think give database SQL projects a shot. I think it's worthwhile giving it a shot, especially considering the fact that it's also in Azure Data Studio today, and that allows you to use these on a Mac as well. So give it a shot. It's natively supported by Microsoft, bunch of add-ins that you have in the form of code analysis and so on and so forth. So if you were to ask me as a personal choice, I would say pick declarative, but it's a matter of choice.
Definitely get that. Well, thanks so much. And thanks again for being on the show. Thanks to our viewers. We put a bunch of links in the description below, so be sure to check those out to learn more. And we hope to see you next time in Data Exposed.